Separation techniques. Separation techniques are those methods that we use in separating the constituents of mixtures. The individual constituents of mixtures behave differently. They have different properties. They retain their respective properties. So if you have a mixture like crude oil, in Nigeria we have lots of deposits of crude oil. The constituent part of the crude oil can be separated so that we can have the PMS, we can have the diesel, we can have the fuel that the aeroplane use. So how do you separate this mixture of crude oil in order for you to get the fuel, the petrol that we use for cars, the one that airplane use, and the diesel for diesel engine? We use what we call separation technique. And the separation technique used here is fractional distillation, considering the boiling point, because the boiling point of PMS is different from that of diesel and is different from that of the AGO. So due to this difference in boiling point, which is a physical property, we can easily separate. Now you buy your rice from the market. You have stone inside the rice. Some of our locally made rice, you have stone, then you have your rice. You can easily use sieving because of the difference in size of the stone and the rice. If you have beans, also difference in size between the seeds of the beans and the stone. So there has to be physical property that can easily differentiate one constituent of a mixture from the other for you to be able to separate them into two. We have different separation techniques, and these separation techniques are actually used for specific kind of mixtures. So what are these kind of mixtures that need these various separation techniques? The separation techniques that we have are sieving, filtration, decantation, crystallization, fractional decrystallization, distillation, fractional distillation, magnetic separation, chromatography, and the rest of them. Now we are going to be looking at a particular mixture and the suitable separation technique used. Sieving. When you have solids of different sizes, like in the sand of different sizes, you have to sieve. If you want to collect specific sand side of a specific from the other one, you have to sieve it out to get the size that you need. If you have your rice and it's contaminated with stone, and the stone and the rice have different size, and you want to sieve out, you want to separate, you use sieving. Magnetic separation is used whenever you have magnetic solids and you want to separate them from non-magnetic ones, as in steel. So whenever you have metals that are magnetic and you want to separate them from non-magnetic ones, you use magnetic separation. We have decantation, filtration, and centrifugation. And these techniques can be used to separate insoluble solid from a liquid. So whenever you have insoluble solid, a solid that cannot dissolve in a liquid, you can separate it from the liquid using either of decantation, filtration, or centrifugation. You also have evaporation, crystallization, precipitation, and fractional distillation. And these techniques are used to separate soluble solid from a solution. When you have a soluble solid, that means solid that can actually dissolve in a solvent. If you want to separate them, then you use these, either evaporation, crystallization, precipitation, or fractional crystallization. Now you have another technique known as distillation, which is used to separate solvent from its solution. You also have fractional distillation, which is used to separate miscible liquids, just like we have in crude oil. We also have separating funnel used to separate immiscible liquids. And we have chromatography that is used to separate solutes from a solution. So how do these questions come out in WAEC or JAMB or NACO? You're going to be asked which of the following methods can be used to separate solids of different sizes. And you have options: sieving, magnetic separation, decantation, and filtration. You are supposed to pick sieving. They're also going to ask you which of the following separation techniques can be used to separate solvent from its solution. You should know that it is distillation. Now, if you have substances that are impure, to get them to be pure, you used to use separation techniques to separate them, to separate the impurities from the main substance. So how do you test for purity? How do you know that a substance is pure? What can you use in checking to know that this substance is pure, that the proper separation has been done? Test for purity. There are two major ways of testing for purity: either by using the melting point or boiling point, or by using the chromatographic characteristics of the substance. Now, impurities make substances not to boil or melt at the specific temperature that they should, as it's written in the book. Actually, impurities decreases the melting point and also increases the boiling point for liquids. Impurities decreases the melting point for solid and increases the boiling point for liquids. So, for you to know whether a solid is pure, when it melts below the temperature that it should have melted, then you know it is impure. Whereas that of a liquid, it will now boil at a temperature that is higher than the normal boiling point. Also, in a chromogram, a pure substance produces a single spot, unlike an impure substance. So that is how you test for purity. So to make impure substances to be pure, they need to undergo purification using any of these separation techniques.